Now let's discuss these methodologies in detail. What is DMAIC, what is DMADV, and what is DFSS? DMAIC is to be used when we have an existing process for it. Okay. When the process is existing, process is running for at least 6 to 9 months, at least should not be a new process altogether. Okay. In that particular scenario, we will follow a DMAIC approach. DMAIC stands for define, measure, analyze, improve, and control. The second type of methodology is known as DMADV, which is define, measure, analyze, design, and verify. This is to be used for new business processes when we have a newer setup, when we want to design something new from the scratch. In that case, we are going to cover DMADV. The third type of methodology is known as DFSS, which is Design for Six Sigma. This methodology is to be used when we are in a very quite mature process, when we are running at least 4 or 5 sigma level. The process is quite mature. Why we want to go for DFSS? Because the cost of the defect is very, very high. Therefore, there are a lot of automations, transformations required, and in that case, we go for a DFSS. However, for our training, we are going to focus on DMAIC, which is define, measure, analyze, improve, and control, because this is for existing processes. Moving ahead, now we're going to talk about what are the expected results from Six Sigma. If you implement Six Sigma in your organization, if you get trained, what all things you can implement. Okay, we can improve the customer satisfaction. Okay, nowadays there are different parameters for customer satisfaction, like NPS, customer satisfaction scores, etc., etc. We can use Six Sigma to improve customer satisfaction. We can reduce cycle time with the help of Six Sigma. Cycle time is one of the biggest opportunities that currently we have. We can increase the productivity, employee productivity. We can reduce the total defects or the errors. We can decrease the work in progress, because work in progress is a kind of a waste in any given process. And if there are too many work in progress, wherein the final product is not being prepared, in that case, we can do Six Sigma implementation to decrease work in progress. Okay, and the final is improve process flows, which means reducing the non-value added activities in a process. So that is something which we are going to expect result from Six Sigma. Now let's understand Six Sigma in terms of different industries, different processes. What is the application? What is the Sigma level which is expected? You can see here in Sigma we have 3 Sigma, 4 Sigma, 5 Sigma, and 6 Sigma. In 3 Sigma, we see that in case of a baggage handling, okay, which means that there are 3,660 passengers with misplaced luggage every day. Okay, if we want to work on 4 Sigma, we say 340 passengers. If we talk about 5 Sigma, it's 12 passengers, and if we talk about 6 Sigma, it's 6 passengers. Okay, so you see that the number of passengers getting reduced the moment we increase from 3 Sigma to 4 Sigma to 5 Sigma to 6 Sigma. The higher the Sigma level is, the lesser the areas of defects, opportunities also. Similarly, for application processing, you see that at 3 Sigma, there were 770 errors, application errors. When the team reaches 4 Sigma, it's 72, 5 Sigma, 13, and 6 Sigma, during the year, only 10 application error requires correction. Okay. Another example of response time where we can see 257 calls each day exceed the 2-minute on hold time. When it comes to 4 Sigma, it's 24 calls each day exceeds the 2-minute on hold time. When you talk about 5 Sigma, 5 calls each week exceed the 2-week on hold time. And when the process reaches 6 Sigma, during the year, only 3 calls exceed the 2-minute on hold time. Okay. And these are some of the numbers which talk about that how much is the defect expected in a million. So DPMO stands for defects per million opportunity, which we are going to cover in the upcoming sessions. If the process has 66,800 defects in 1 million, we say the process is at 3 sigma. If the process has 6,210 defects, then we say the process is running at 4 sigma. If the process has 230 defects in a million, we say the sigma level is 5 sigma. We would call 6 sigma process when in 1 million we have only 3.4 defects. So 3.4 defects per million opportunity is a 6 sigma quality process. Okay, and then we have the yield percentages also mentioned here. 99.99996 is when this is our yield percentage or accuracy percentage. We would call this as a 6 sigma project.